Okay, so welcome to this math video where we will be finding the tangent plane to this function of two variables at this point. So the first thing we want to do is form the equation of the level surface. Okay, so we want to create basically a function of three variables that equals a constant. And we can do that by simply subtracting z on both sides. So f of xy minus z equals 0. So that's the first step. And we can call this g of three variables, x, y, z. And that equals, obviously, a constant. The next step is we want to now get our gradient vector of g, which is simply going to equal the partial with respect to x, partial with respect to y, and then we have this minus z tagged on at the end, so that's just going to be minus 1. Okay. Now just bear with me, just thinking about the next step. We've got our partial. Right, so this is basically our normal vector. Actually, let me do that in another color. This is our normal. This is the normal vector. So we now need this. We need this normal vector to be perpendicular to all the vectors in our tangent plane, right? And we can define that hypothetical vector as x minus x0, y minus y0. But how about z? Oh, I see. And then z minus f of x0, y0. Okay. So this is that hypothetical vector, and I beg your pardon, I've actually made a mistake here, because this should be in vector form, so not brackets, but, you know, the pointy ones. And now what we got to do... Oh, and let's call this... Actually, we don't need to call it anything. What we now need to do is we have to use the dot product to combine them, and the result will equal 0 if they are orthogonal. So we can say... I'll go back to... I'll go with blue here. We can say... let's just have a little look. So we got f of x, xy, f of y, xy minus 1 dot x minus x0, y minus y0, z minus f of x0, y0, and that has to be equal to 0 if they are orthogonal, which we want them to be. Recall the dot product of two perpendicular vectors is 0. Okay? And so what we have to do now is we just got to compute this, and that will give us our answer. I'm not going to compute that because it's a little bit messy, but this will help you conceptualize this concept of finding tangent planes two equations in 3D. So I hope you've enjoyed the video, and I will see you next time.